Hey guys, as promised, I am making a video for you so that I can go over some material that you're going to need to be able to do your homework. So hopefully you definitely pay attention to me today, even though I'm not here in class, so that you'll be ready, A, to do the homework, and B, to be able to do the test that's going to happen next week. So you should have finished this problem that's on the screen right now. It's the very first problem on your sheet that you have. And let's just go through the steps that you hopefully did to solve it. The very first thing you should have done, of course, as always with every force problem, is you draw an FBD. So hopefully you did that. And after you drew your FBD, you can set up your force equation. And then when you set up your force equation, you should notice that, oh, the information I gave you here, it should allow you to find the acceleration, and with that, you should be able to solve for the unknown force. So when you did that, hoping you did this already, you should have gone, this is your acceleration, 3/2 meters per second, and your force was 9/2 newtons. All right, so I'm hoping you were able to figure this out, at least with the help of your neighbors, if you weren't able to do it yourself or anything like that. All right, so I'm gonna move on then to the next problem. So the next problem, take a look at the next problem in your worksheet, and we'll work through this one together. All right, so let's do the next one together as a class. So the next problem is the car on a string. And I do want to, this is supposed to be like the car on the string demonstration I showed you in class last week, whereas a car tied to the string that's just turning in a circle. And then notice I said, let's just pretend the string is purely horizontal. So the very first thing is you should be drawing an FBD. So hopefully you draw an FBD. Should be a very simple FBD. So why don't you go ahead and draw an FBD. All right, and then when you draw an FBD, I'm going to pause here while you draw your FBD. And then when you draw your FBD, make sure the acceleration is to the center of the circle like you expect. All right, and when you draw an FBD, you should end up with something that looks like that, hopefully. Okay? Once you do this, then you can set up your force equations, right? Now, when you set up your force equation, you're going to have this, at least in the horizontal direction, right? So A equals Ft, this is the horizontal force divided by mass. All right, you could do in the y direction too, except all the y direction would just tell you is that the two vertical forces are balanced. So in the x direction, you'd have A equals force of tension or force of rope. You said force of rope, that's fine, divided by the mass of that car. Now here's the only problem then. Before, when you find the acceleration for this problem, you probably did something like either change in v over change in t, or you use the velocity equation, right, to find the acceleration. So you probably used one of these two equations, which are actually the same equation, right? So you probably plugged in final velocity of 5, initial velocity 2 for the time, and then solved for a, or 5 minus 2 over 2 here, and got 3/2. All right, but notice that for this new problem, you can't actually use either of these two equations. Why? Because the speed is not actually changing, right? What are you going to plug in for initial speed and final speed? It will be the same number, right? And according to this equation, it'll tell you that the acceleration is 0, but we know the acceleration can't be 0, right? Because we know it's accelerating. So clearly what it means that these two equations are not appropriate to use for uniform circular motion. All right, so we have to have another equation to find acceleration for uniform circular motion. All right, so that's what this is right here. When an object is in uniform circular motion, the acceleration is v squared over r. You do not use the velocity equation, the vf equals v naught plus at, or the a equals change in v over change in t. You do not use that equation for UCM. You use this equation for acceleration. Notice there's only one v here. That would be the speed that the object is going. And this r, of course, would be the radius of the circle that the object is traveling in. Okay, so then what does this mean then? Once you have this formula for acceleration, that means when you set up your force equation, okay, A equals the sum of force over m, all you do is replace A with v squared over r. So you set up your force equations just like any other problem. The only difference is that UCM, you use A equals v squared over r. All right, so then let's go back to our problem we had with the car on the string. So here I set the force equation for the y direction. Remember, the y direction sort of doesn't really tell us much. Since the acceleration is 0, it just tells us those two vertical forces are balanced, good to go. But in the x direction, we can set up this. All right, the same tension over mass that we had before, but we're going to replace A with v squared over r. Right? So then you just plug those numbers in. That v was 0.5 meters per second. The r, once again, you have to be really careful, even though it says 40, remember that's 40 centimeters, right? So you need to convert that to meters. And same with this mass right here, when it says 100 grams, that needs to be in kilograms. So that mass should actually be 0.1 kilograms. So when you plug that in, you should be able to solve for force, and whatever force tension you get is what you get. Actually, I didn't solve this out myself, but hopefully you can solve for force tension pretty easy. Or just plug this stuff into a calculator and get what you get. All right? So this is how you do the second problem. And so hopefully you can confer with each other and get the force of tension. Everybody gets the same force of tension for problem 2. So I'm assuming that everybody has now been able to get the answer to the second question, right? And you can do it. If you are having some problems, maybe you can ask to pause the video while you guys discuss it as a class and make sure you get there. But if there are no questions, I'm just going to move right on and have you work on the third problem. So actually, why don't you go ahead and pause the video now, and you can work on the second problem with your class. All right, pause. Okay, so here is the setup of the second problem. That is the person on the merry-go-round of death, no railing. Hopefully, once again, this person is not wearing wooden clogs, is wearing rubber-soled shoes. As you can see, I drew the sole in the shoes very carefully. And so I asked you to draw an FBD. Hopefully you drew an FBD, and then you can find the sizes of all the forces acting on the person. So I'm hoping your FBD has 3 forces, and you've labeled them, right? The 3 forces would be gravity, normal, and that inward force would be the force of friction. So when you calculate it all out, hopefully these are the numbers you got. You can check your answers. Once again, pause this video if, as a class, you feel like you need to talk this over and sort of figure out if you can get these numbers as appropriate, okay? So if you're all good, then we'll move on to the back page and do vertical circles. Vertical circles are a little bit more complicated. It's still not too bad, but they're a little bit more complicated. All right, so here is this vertical circle scenario, right? So you're spinning this ball in a vertical circle. Now remember, like we talked about before, vertical circles are UCM at the very bottom and at the very top. At the very bottom and the very top of circles is basically UCM. On the sides is not UCM because it is speeding up and slowing down on the sides, right, as it goes up and down the circle. But at the bottom and the top, it's basically going constant speed through the top and a constant speed through the bottom. All right, so here's the information that's given to you. So go ahead and start to answer this problem. Let me give you some hints. Remember, draw the FBD. Draw the FBD. And when you set up your force equation, properly, looking at your FBD. So the most common issue is that people don't have all the forces that are in FBD in your force equation, all right? So why don't you try working on this? So draw your FBD. Hopefully you've drawn your FBD. I'm gonna pause right now while you draw your FBD. Everybody is drawing your FBD. Try to make it accurate in terms of the lengths. So you want to make the lengths appropriate for, you know, the imbalance that would be appropriate to have the acceleration the direction you think it should be. All right. So talk it over with the neighbors. Make sure your FBD is correct. Hopefully it looks like something like that. Notice my forces are imbalanced in the direction of the acceleration, correct? Then you can set up your force equation. Notice how many forces there are. That should tell you how many forces should be in your force equation, right? So you set up your force equation. Bam. Notice what I did with A. I didn't just write A there. You could write A there, but I already know I'm going to replace A with V squared over R. So I just write V squared over R from the very beginning. All right. Notice I do tension minus gravity. All right. Don't just do tension. There are 2 vertical forces here. you need to have them both in your force equation. Now, when you plug your numbers into here, you should be able to solve for force of tension. So I think if you do this right, you do end up getting a force of tension of being that. So why don't you just plug your numbers and check to see if that. So go ahead and pause it to make sure you can get this number. And yeah, if you can't, talk it over, of course, with your neighbors and make sure you can get this answer. So I'm going to leave you guys to do the next two problems, the next two hill problems. Those are two problems where at the top of a circle. Try those next two problems yourself as a class, all right? Work on them together. Pause this video and go ahead and work on them, and I'll catch you once you all finish those two problems, and then I'll go over the answers. Go ahead and pause it. Okay, hopefully you guys have finished those two problems. If you haven't, pause the video and make sure you do those two problems. All right, let's go over the answers. So this was the first hill problem. Oh, looks like I have this car going the opposite direction of the car that's in your diagram, but whatever, answers should be the same. First thing I did is I actually found the acceleration first. You don't have to do this as a separate step. You could have included this in your force equation, all right? Notice this is, of course, your FBD, right? A lot of people mess this one up because you set up the equation differently. Here's the trick to this question, all right? Knowing that the FBD is the acceleration, the acceleration is down, I would actually set up my equation Fg minus Fn over mass, not Fn minus Fg. I would do Fg minus Fn over mass, all right? Because if the acceleration is 9 down, then we're going to assume that down is positive, which means you do Fg minus Fn. So if you didn't get this for your normal force, if you got a normal force that's bigger than gravity, it's because you did Fn minus Fg when you probably should have done Fg minus Fn if you're going to use positive 9. Now, the other thing you could have done is done negative 9 as your acceleration, and then done Fn minus Fg, right? So if you're going to do positive 9, you do Fg minus Fn over mass, or you do negative 9 and do Fn minus Fg over mass. In either way, you should get 4 newtons as your normal force, okay? And then for the last one, okay, notice that you have tension and gravity both pointed down, which means then when you set up your force equation, you should have A equals both of these guys, Ft plus Fg, all right? And then if you do that right, you should get the force of tension being, oh my God, 66.6. That was definitely intentional. Yes. Anyways, hopefully you got that right. You can talk it over if you didn't get that right. So if you still need to talk it over, you can go ahead and pause the video before you go into the very last two questions on this sheet. Okay, we're on the last two questions on this sheet. The last two that will really help you with your homework. So notice all the problems we've been giving you so far, I've just given you the velocity. Like the previous question, the one you just did, the velocity 4 meters per second. Or like here, 4 meters per second. Or here, the velocity right here, 6 meters per second, stuff like that. But oftentimes, there's another way to give you the speed, or like oftentimes you won't even know the speed. Like if I'm spinning this car in a circle, I don't really know how fast that car is going. But one thing I might give you is something called a frequency. Like I might tell you, for example, that first problem, that the frequency is 2 revolutions per second. And from that, you should be able to find the speed, all right? So note that the object speed is sometimes given as a frequency. You should be able to calculate the v from f. And the easiest way to sort of think about it is that you have 2 revolutions per second means that the object travels 2 circumferences every second, right? So if you think of the distance being, 2 circumferences, circumference is a distance, right? So if you can calculate the circumference of that circle and you know it does 2 of those distances every second, you can use that to find the speed, right? So you should hopefully be able to calculate the answer to that first question, right? Well, I sort of gave away the answer down there. The answer's down there. But hopefully you can sort of recognize, okay, 2 pi times 0.5, that is the circumference, right? Then you're going to have 2 of those because doing 2 revolutions, so 2 circumferences, right? And then down here, that's every second because that happened in 1 second. So that was the distance divided by the time, that would tell you the speed of this thing. So you can just use this to find the speed. Now, what do you do with this v? Then you can plug that into v squared over r if this problem went on kind of past this. All right. So why don't you go ahead and try the last problems on your sheet. So the last problem on your sheet gives it in terms of a period. So here's, what if I gave you the period? Can you find the velocity? Now remember, period is sort of related to velocity. For example, it's also, you know, you can think of it, well, this object is traveling the distance of one circumference in the time of one period. So if you know the distance, aka circumference, and you know the time, which I gave you here, is the time for one period, you can thus find the velocity too as well. So hopefully you can try that out. Check to see if you get this answer, right? And once again, don't just copy this answer down. Make sure you understand where it comes from, all right? And then, so if you can do this full sheet, then you should be able to, if you have any time left in this class, you can go ahead and start on your homework and work on your homework and try to see how far you get from there, okay? All right, so that's all for today's video. And if you are in 6th or 8th period, I'll have another video for you for Wednesday, okay? All right, see you guys later. Have a great day.